All right, guys, this is the 2015 AB and BC exam, number 4, part D. This question is ridiculous, and I would not expect you to get it right the first time through, but hopefully what I'm doing up here makes sense to you. All right, so you have this dy dx, it's giving at the very beginning of the question. In part D, it says, find the values of the constants m and b for which y equals mx plus b is the solution to the differential equation. All right, so if this is a solution, what that means is that if I integrate this, I get y equals mx plus b. Like, you know how in the previous part of this question and other slope field questions, you find the particular solution to the differential equation? Well, you integrate dy dx to get to the solution, all right? So here, if I integrate dy dx, I get y equals mx plus b. So the inverse of that is if I derive this, I should get dy dx, which is 2x minus y. So if I derive this guy, I get dy dx is equal to m, and I know that dy dx is 2x minus y, so I'm here. All right, and I'm going to do a bunch of substituting. Now, all this substituting I'm doing is in an effort to get just m's and b's because that's what I'm looking for. So right now I'm here, okay? That's not an m or a b, but I know that y is equal to mx plus b, so I can replace y with mx plus b. Distribute the minus sign, it puts me to here. I did a little bit of a factoring cleanup job, which puts me to here. Okay, so now 2 minus m times x minus b is equal to m. Well, if only I had an x over here, I could start matching some stuff up. And I can create an x out of thin air as long as I multiply it by 0. So that's what I did. 2 minus m times x minus b is equal to 0x plus m. And then you can start matching stuff up, right? So if these are equal, then like this has to be equal to this, and this has to be equal to this. So 2 minus m is equal to 0, add m, so m is equal to 2, and then negative b and m have to be equal to each other, so b is equal to negative m. You already know what m is, so you can just toss it in there, and so b is equal to negative 2. All right.